from your favorite artist electronist, Mr. Q12 here. What I'm having here is the simplest oscillator possible. Very extremely simple, and you will laugh as well as I am, because this was the idea actually, to buy this very tiny and cheap oscillators. Pretty much, it's a single LED that is auto flashing by itself. If you connect it, you need to put also a resistor. As you can see, it's all SMD components. The auto flashing LED is SMD 0805 marking, and also a matching resistor that I found. It's a scrapped one. It's 1 kilo here, what I put. So it's self-explanatory what I'm having here. I'm powering with with 5 volts there. It's consuming 10 milliamps because I'm having all this stuff that I'm having here. This is the power. My first test that I did, I made this little cardboard circuit that you are seeing here. Is, like I said, it's self-explanatory. It's receiving a positive 5 volts there, negative 0 volts here on this other side, and between the resistor and the and the auto flashing LED is a pad from which I drag the signal wire. This is an S. I drag this wire there, and originally I tested it without this transistor that you are seeing there, so bare like that, and I tested it with my counter that I'm having here, and it didn't work at all, and I was hoping it will work, but by itself it's not powerful enough, or the counter clock expects a minimum of voltage. Because it's flashing so slow. This is the slowest that I could find. There are this is slow, there are medium, and there are fast. I have a list. Let me check. This is the flashing frequency. So the slowest is 1.5 hertz, which I have. And this is medium. You'll see a little bit. It's 12 times per second. And this is actually fast, which is 38 times per second. And it needs of course the voltage, and also the current is specified there. And this was important because I got a hint that I have to use a resistor. I was thinking maybe they will work directly on 5 volts, but after seeing the voltage and the 20 milliamps per LED, I start to think about it, and I didn't test it at 5 volts directly. So I put a resistor, and it worked fine. Initially I put a 10 kilo resistor, and after that I put 1 kilo, as you are seeing it on my table there. Of course, it is beating 1.5 times per second. It's not 1 per second. It could have been interesting to beat 1 per second, or at least 2 per second. And yeah, it sucks. Actually, I have the circuit, and I will show you. And this wire, this signal wire, is going to the base of the transistor, and this transistor is driving the signal, and is activating the signal wire input for this counter. And also this signal wire, this clock pin of this 4017 counter, number 1 is, I put this LED there, and it's good enough. If I'm seeing it blinking, it's good enough for me. I can understand it is working. 5 from 5 to, you see, from 5 to 5, but yeah. So it is counting to 10 times. It's a very minimalistic and very cheap blinking or flashing or clocking, whatever you want to call it. It's a very cheap, very easy to make. Unfortunately, you need a transistor, and I was thinking to add here on this board SMD transistor as well, with a resistor on its base as well. You can see the resistor for this base transistor as well. It's a BC548. Here it is. BC548. This is the pinout that I'm having it there as well, and that's it. Very simplistic, very minimalistic blinking circuitry. Unfortunately, it involves a transistor, which I was hoping it was not required, but it doesn't work. It doesn't work at all. If I'm connecting this wire directly to the counter, I can actually show it. I can take it out from here and put it directly here on the clock pin, and that clock is not working as well, and my counter is not counting either. And let me actually reset it. And nah, it doesn't work like that. So this transistor, the idea that I had is that it is amplifying a little tiny bit. It is amplifying it there, and yeah, it's very cute circuit. I really like it, and I hope you like it as well. And this is a good, very good testing blinking circuit, especially for clocking. If you want to clock something for testing purposes, you can get slower, like I have, or even more faster than this, and you can minimize then your entire circuitry very much, making a blinking clock. An oscillating clock or something, to drive for testing purposes, to drive whatever chips, clocks like I'm having there, or counters, or to test the counter if it's working, etc. It can be, or as simply as a signal LED that is just blinking, and that's it. When you power something, like a signal, something is wrong, or be aware something is activated or something. It's very cute. I actually find about this blinking LEDs from Big Clive. He is an English UK YouTuber, and he actually made something very cool with them. He made like a retro computer with many LEDs. I believe he's having 500 or something, or 1000 LEDs, but bigger LEDs, not this SMD version that I'm having here. This very cool project that he is having, but my purpose, why I bought them, one for curiosity, absolute curiosity, and the minimum price I could find them, $2.4. I pay for 60 of them. And second, it's a practical device. I can use it as a source of dipping, of clocking, and that was my idea originally. Before I bought it, I was thinking what I can use it for, and this is the only thing that I was thinking, to use it as a testing circuit board for my testing that I'm having, and to clock something, and it's interesting. It's a novelty, and unfortunately there are bigger sizes, but they are more expensive. This 0805 size that I'm having here is a bit hard to solder it, but making abstraction of the very small size, it's kind of manageable. But there are other sizes and other cases. There are 3mm LEDs, I believe even 5mm, like this LED that I'm having here, with legs, very easy to connect them. But I really wished to buy 1206, not 0805 that I'm having here. So 1206 is my way to go for everything. They are a bit more easy to manipulate and to use them. And probably these are so small and they never sold, or they are selling very badly. And yeah, probably, I don't know. I'm just guessing. And yeah, and I have 6 colors. I choose this yellow one because, yellow for me represents testing, for testing everything, signal testing, whatever. All right. Hello, everybody. This is an update for for the circuit. Previously, I had this BC548 transistor and some components there, 1 kilo on its base here on the breadboard, but I took out everything else and I mounted a single SMD transistor. Doesn't matter what transistor. I forget to mention this detail in the previous movies, but doesn't matter what transistor as long as they are BJT NPN transistors. I should actually write that. So any, you see, any BJT NPN transistor, whatever the name, whatever it is. In my case, I'm using this guy here. It's a 2N3904, 40 volts, 200 milliamps, very weak transistor. It's an NPN, and the markings on it is 1 IM. That's what is having written on the chip case, and that's what I'm using. You can see them there. You can zoom in. You see, you can actually read on them on some of them 1 IM. You see, so they are. This is the guy that I'm using. Let me actually zoom in to see if you can read it. Probably, yeah, 1 IM, a little bit. You can read it. But it's not very gloriously clear. Okay, so what I have here is exactly the same circuit as I had it before with that BC548 transistor. This through hole is exactly the same circuit that I had it before, and it's working absolutely. It should. It got out from here, motherfucker. The entire probe of the oscilloscope pulled out the wire. So it is functioning absolutely fine. Unfortunately, it cannot work without that transistor at all. Simply by getting the signal from here between the LED, the auto blinking LED, and the resistor. It's the same configuration. Here is the positive, that is the negative, and from here I'm taking the signal through 1 kilo resistor, SMD resistor, through the base. You can see here the diagram of the transistor, how is the pinout. So the base, 1 kilo on the base, and from the collector from here is the positive rail, and through its emitter, which is this pin, last pin here, exactly as you are seeing it here, is the signal wire going to any clock pin of any IC integrated circuit. Here inside I'm having 4030, I believe, if I remember right, and this is on one of those chips. There are 3 integrated circuits for each digit that I'm having on the display, and on one, and they are cascading, and one this signal wire, this yellow signal wire that is coming from this device, is on one of the clocks of one single chip there. So it can read the signal. I actually put my oscilloscope here, as you can see, and I'm reading that signal, and it's very good actually. It's quite rectangular. It's a square wave. What I am interested in is maximum voltage that is on that signal pin is not exactly 5 volts. This is the maximum that I'm supplying with 5 volts. And it's not the maximum, it's a little bit less than maximum, it's 4.4. On minimum voltage is not going down to 0 volts, it's going down to positive 1.7, 1.8 volts. I believe it was, this voltage minimum, it was higher a little bit, like 2 volts, probably 2.5 volts or something. But I took the same measurement here directly in the middle. Before I added the transistor, and it was the voltages were more close together, and now it's having a larger difference. Pretty much is much more definitive, positive, and quite low. I was thinking to add from this single point here resistor directly to the ground, 10 kilo or something, or even 100 kilo. The idea was to obtain here a clear 0 volts. I changed this 1 kilo resistor here, the base resistor of the transistor, with a 10 kilo. And the minimum voltage and maximum voltage here, the difference were not too great, was kind of the same as it is right now. very tiny difference, very tiny difference. I didn't even note it down. I should have, but a couple of probably 1 or 200 millivolts, very small difference. It didn't affect anything. It didn't lower down this minimum voltage here. I got some strange results. So yeah, it is fine as it is right now. it is working. It's all that we have to get out of this. So yeah, it's good enough. It's good enough. It should have been interesting to get a 0 volts and a 0 volts and a 5 volts, or well, the maximum voltage I don't care, but I would like very much to have a 0 volts here, or very close to 0 volts, a couple of millivolts instead of 1.7 volts like it is right now. I was thinking probably this can be made better with an op-amp instead of a single transistor. So that op-amp, you can set it to trigger under a certain or over a certain value, and when it's not triggered, goes down to 0 volts pretty much. And that could be a better circuit, but it will complicate a little bit this simplicity that I'm having here. This is quite simple and quite elegant, I may say, but probably with an op-amp instead of that transistor. And of course you have to program that op-amp to a certain level to flip, to switch, and that's it. So that's my experiment with 10 kilo with other values for that base resistors, and it doesn't change anything that much. Not that important change. That's it, all that I wanted to say. But as it is right now, it's good enough. You know, it is good enough, and it is signaling. It's creating a signal, positive and negative. And this is the circuit, as you can see. You can read it there as well. It's not too much about it. It's very simplistic. All the work, all the blinking is done internally from this auto blinking LED. I cannot change its frequency. It's a fixed frequency. It's 1.5 hertz around. It's not exactly 1.5. It's my frequency meter is reading 1.58 hertz. So probably it depends. It varies with temperature. So it's very unstable frequency. It might differ a little bit with temperature, with a lot of stuff. So it's not a fixed, perfect, constant frequency. But it's good enough, you know, for testing and for making something. Usually for testing, it's very good, and I like it. This is its entire purpose why I bought these LEDs for this little auto clock, you know, circuitry that I'm having here. It's very small. It's as small as my finger, my tip of my finger, and especially when it's made with SMD components, and it's quite cute. All right, this is it. Thank you very much. See you later. Bye bye from your favorite artist actress, Mr. Q12.